part of the board scared you? It's an easy freebie point right here. All you had to do was read.
What part of
Who can read?
I can't do it.
Who can read? No, but that is a good guess. Table 1 can have a point. No, the board doesn't say anything about doing word problems. Although, sadly, that's what you walk into when you walk through the street. Oh, table 4? Yeah, whew, counting. Table 4 gets the point because they can read. In orange it says, test on number theory on Tuesday. Test on Tuesday. So, let's talk about that. You know from yesterday's activity, you've got classifying a number down. You know if it's real, rational, natural number, a whole number, an integer. I think you know the difference. We're going to confirm that with a checkpoint later on during class, but that's the majority of the test is can you classify a number. I'm going to put 1 or 2 problems of is this situation discrete or continuous, but I swear it's going to be easier than the checkpoint, more straightforward than the checkpoint was. And then the remainder of problems are going to be what we're talking about today, but there is good news. So it looks kind of scary because we're talking about properties of numbers. The good news is I'm going to let you keep your tiny sheet forever and use it on the test on Tuesday. Now, I do understand that there is a solar eclipse on Monday. I'm not dumb. Got it. If you're not going to be here on Monday, which I totally understand. I wish I had cool glasses. I don't. If you're not going to be here on Monday, I'm going to go ahead, good grief, and give you the study guide tomorrow then. That way, that's all we're going to work on Monday. That way you go ahead and have it. Monday afternoon, I will post the key to the study guide. And then Tuesday when we take the test, you will turn in the study guide for an easy 30% grade. But my God, if Taylor doesn't have my exact if he doesn't have all the answers, like I'm posting the key. He's going to have it correct. He's going to get a great score in the 30% category for no reason. Okay, are there any questions about that? At least now it's less terrifying. Thank you. Okay, I need help with my one math worksheet problem of the day. We're going to save the other one until tomorrow. Can anyone help me with number 11? Yes, table 5.
All right, so there's maximum seating of 69 people.
Right.
So the coach, the principal, vice principal, and 22 girls.
Right.
So you would take 69.
Okay.
Minus 3.
Minus 3. I get.
Give you 66.
Right. Okay.
Okay. So you'd also subtract 22 girls.
Okay. And you get.
44.
Okay. Now what?
It is.
Well, you can help him.
It's going to be.
I can't hear you. What now?
You take 22 girls, multiply by 3, that's 66. Add the people in charge, and that's 69.
Okay, that's great. I still don't understand the answer.
They can invite 3 people each.
Oh. Okay, table 5 can add a point, and they were going to get to add 2 points until that one fatal mistake. Can someone nicely tell me what the fatal mistake is? Yes, table 4.
Okay, so the 66 minus 22, that is the 22 girls.
Yes.
They count, and so you just take 4 and divide by 2. And then that's how many tests.
Divided by 2?
20.
Yeah, because it's just as like 22. Because that's how many girls.
Table 4 can have a point. Okay, different table want to take over? Explain in English.
And then you get.
Yeah, table 3.
So the minus 22 and the 66. So the count of 22 girls.
Okay.
So 44 are the remaining seats.
Okay.
You take now, if each girl were to bring how many people to figure that out, you take 44 divided by 2. That would tell you how much guests each of the 22 people can bring.
So what number did you get?
2.
Okay, so let's go back to what Table 5 did, because that's what I started writing. They knew to take the 69 and subtract off the principal, the vice principal, and the coach. They then realized, hey, I should subtract off the team members themselves, and then 44. So there's room for 44 guests. And then if we take those 44 guests and we split them evenly between the 22 players, it means that each person gets to bring 2 guests, 2 people each. And I believe, I really like, Table 3, you had a point, by the way. I really like Kaylee, before she got caught up in, is it 44 divided by 2 or 22? Kaylee was trying to explain nicely that their mistake, or Jake's mistake up here, is that he's considering, when he thinks of the 66, he's got to remember that that's including the 22 girls. Okay. That's not bad. There's nothing wrong with that. You know, I'm a math teacher, so what did I do? Did listen to you. What do math teachers do? Because they're ridiculous. What do they do? Oh, I would have done, let's see. There are 22 girls. 22 times x plus 3 equals 69. So 22x equals 66. And I would have gotten x equals 3, so that's incorrect. So, but then maybe I would be smart enough to remember it's actually, I don't know. So I would try to write an equation, but apparently I failed at that. So there's nothing wrong with that. Please fix it. Or do whatever. Tell me what you need. Yes, dear. Okay. Whew. Yes. Supposed to make mistakes. Woohoo. Yes. Everyone can get a point because Ms. Compton made a mistake. Okay, so I feel like you're good at classifying numbers, or at least someone in your group is okay at classifying numbers. There is only one group in the room that has me concerned, and I'm hoping they're gonna ease my fears during our checkpoint today, because I would hate for them as a senior to really not know what they were doing and then take a test on Tuesday and show me further they don't know what they're doing. That would be the worst. The worst. Okay, today, yeah, it really is a walk of shame. Today we're going to talk about some properties of numbers. Some of them, which table is it? Which table is it? Was it 2? Take your point away.
I would turn my phone on and my phone had Oh, that's dirty.
Yes, it is awful when people's phones go off inside. Okay, so I made these cute little handouts that say the different properties, and I'm going to leave them on the board henceforth. However, some of these properties are not on our cute little handout of the day. So I guess what I'm really saying is our cute handout for today is cute, but it is not conclusive. There are more properties of numbers than just what is listed on the cute handout. So long story short, Hunter sits really far away from the front of the room. He probably can't see these tiny things. If for instance, he realizes the transitive property is not on his cute little handout, but he needs it because it keeps coming up, I don't care if he writes it on his cute little handout. As long as his cute little handout doesn't suddenly contain all the answers to my tests, the cute little handout, he can put on it what he needs. Again, he gets to use this handout on the test on Tuesday. Okay. Let's see. And then the other thing I was going to say, if words will come, fail. The other thing I was going to say, besides I need a magnet, I have magnets, why don't I? I'll fix that. I don't know what else I was going to say. I got distracted with myself. Darn idiot. Okay. Properties of numbers. Oh, I know you're not color people. Maybe you are. I'm going to use 2 colors at least. If I were you, I would have 2 colors. So if you want to get a color out of the drawer, I would understand. coordinates for today for the little boxes. 2 colors are probably needed.
You want to grab the colors down
You give me a red and a black.
Now, why do you need 2 colors? Because we're going to explain the property using letters. That's how math teachers roll. And then we're going to actually try it with a real math example with numbers. That way people don't cry. Fail. Okay. So, we're actually going to go out of order because there are some of these properties I doubt you know by heart, but some of these properties you actually do. So we're going to go out of order because I bet you know some of them. In fact, let's just start at the bottom for the moment. Notice that the bottom box takes up the entire thing because there is no property, no distributed property for addition. There's only one that involves addition and multiplication. Can you tell me a math example of the distributed property for a point? Actually, for 2 points. Yes, table 2.
When you have it in parentheses and there's the outside distributed.
Tell me some numbers to put inside.
X plus 6.
5 plus 3.
Okay, if we had this as an example, and we were actually going to use the distributed property, what would we do from here? What does that mean?
Multiply everything inside the parentheses by 3.
Okay, table 2, you can have your 2 points, which is good since he had lost one anyway.
Yeah.
So 3 times 5 plus 3 times 3. And I know Miss Compton's ridiculous by writing that line. I get that. So it's really 15 plus 9, which is 24. And do I think that 8 times 3 is 24 anyway? Yes. But you and I both know you need the distributed property, and it comes up all the time. Okay, in letters, we were to write the distributed property. I'm going to pick random letters. If we did A, B plus C, then if we distributed, we would have A times B plus A times C. You've been doing the distributed property for a long, long time. So what's going to happen is we're going to go through all these properties, and then I'm going to give you this worksheet. And on this worksheet, you have to identify which property did the problem use. Which property did the problem use? Did the problem require the distributed property? That's what we're going to look for. Okay, and then let's skip around a little more. Let's go to the commutative property, the second one down. Does anyone know anything about the commutative property? Yes, 5.
A equals B, and B equals C, and A equals C.
That's the transitive property, but that was super impressive, and you can have a point. Different property. It's on this handout there. You learned it in geometry. Don't look at me like I'm crazy. Again, if you want to add the extra properties that might come up to the back of this handout, that would be wise. So wise. Table 3, you had a hand. No, you didn't. Oh, I'm imagining things. Yes, dear. That's exactly what he said with the transitive property. Okay, what if I write, I'm going to stick to A's and B's. So if A plus B equals, if I reversed it, what would it be?
B plus B.
Okay, table 2, you can have your point. B plus A. So the commutative property is saying, hey, we can add numbers in either order. It also says the same thing about multiplying. We can multiply numbers in either order. A times B is the same thing as B times A. For those of us with big handwriting, I'm sorry. I wish the boxes were smaller. Here's where that second color comes in. The A's and B's seem great, but let's face it, we're going to need some numbers. So isn't 3 plus 5 the same thing as 5 plus 3? Either way, isn't it 8? And then isn't 3 times 5 15? And then isn't 5 times 3 15? So it doesn't matter what order we do it in. for 3 points. There is a topic you discussed last year in your math class, in an algebra 2 with trig or in pre-cal. There's a topic you discussed last year in math class where the order actually did matter. Order actually mattered when you multiplied these things. Do you know what that thing is?
Plus or minus
Wait.
Not the quadratic formula. There's a topic, there's a certain thing you talked about in math class.
Equilaterals.
There's a certain thing you talked about in either algebra 2 with trig or pre-cal. Yes, dear. And now you can have your 3 points.
Oh, dang.
If you've forgotten all about a matrix, don't worry. They're going to come back up in discrete because I told you we tend to spend our time on the most random things ever. Matrices are something we spend a lot of time on in here because they're a great way to store data. In fact, we'll talk about how your favorite, well, at least it's my favorite, about how Netflix uses matrices to make recommendations to you. We'll talk about that later on. But a matrix, it was specific about what order it was in. The dimensions had to be specific in order to multiply. So this is not true with a matrix. That's just side knowledge. Do you have to know that for the test on Tuesday? And no. Again, all you got to do is have this handout and then identify what property is what. Okay. Yes. Okay, so you can always get bonus points out of me by being extra. It's always true. Okay, so the next property I want to go to is one I believe you know as well, and it is the identity. Now, the identity is different with addition and with multiplication, and it's different. So I'm needing to know, with addition, what number do we think about when we think about the identity? It was you, right? You whispered it, and then she said it, right? We'll give table 1 a point. They need a point. Okay. The identity is when you add something to a number, how do you still end up getting the number? For instance, your favorite number is low. 9. 9 plus 0. Isn't 9 plus 0 9? That's the only number. 0 is the only number with addition that works like that. If you do 9 plus 1, you're going to get 10. If you do 9 minus 1, you're going to get 8. The only number where when you add it to your original, and you still get your original, is 0. And you knew that. You just didn't realize it was called the identity property. Now that you know what we're looking for, does anyone know the identity property of multiplication? Yes, table 2.
Alright, so it's going to equal 0. Anything multiplied by 0 equals 0.
That is true, but we're hoping to get back ourselves. Identity meaning we're hoping to get back ourselves. All tables can have a point. As soon as they change the classroom name to Fairland, it'll be great. But for now, you live in Comptonville. Okay, 9 times 1. Oh my goodness, y'all be over dramatic. 9 times 1 really is 9. 9 times 1 is the only thing where it times itself is 9. Okay. Yes, we ought to. 9 times 1 really is 9. Okay, the identities are really easy to notice. If you mess up an identity, something has gone wrong. Terribly, terribly wrong. Okay, let's skip around further. We'll come back to inverse in just a second. Let's go to closure, because I don't think you know that one at all. This one's probably the most difficult one of the day. I guess that's what made the top of the handout. Let's say A plus B equals C, or A times B equals C, or I could have done X, Y's, and Z's. It doesn't matter what letters I choose. You're like, Miss Compton, I know that 2 numbers added together give me a third number. I know 2 numbers multiplied together give me a third number. I get that, but you and I just spent a whole lot of time on identifying what kind of number it is. Is it a real number? Is it a rational number? What kind of number is it? So, specifically, A plus B equals C, where A, B, and C are, and then I'm going to put that fancy R for real numbers. And I'm going to write the exact same phrase over here, where A, B, and C are real numbers, the fancy R. Okay, what does that mean in English? It means that when we add two numbers, that third number we get is a normal, regular old, it's probably even a rational number. For instance, I see a natural number, I see a natural number, 3 plus 6 is, I get out a natural number. It tends to be they actually stay in the same field. In fact, let's stick with that mentality. If I take a natural number and multiply it times a natural number, I end up with another natural number. Now, could I do fancy examples with fractions or decimals? Yes, I could. But if I did 1/2 times 1/2, I get 1/4. It's a fraction, which is a rational number. It's a rational number times a rational number, and I still end up in a rational number. You're good, but you can't suddenly make pi just pop on out unless you started with an irrational number. I don't think you're that good. Maybe you are. I don't know. Okay, so closure sounds really silly, and it doesn't come up as often as you wished it would. But all it means is if the two numbers are regular old numbers, then the third number is going to be a regular old number. You're like, that's common sense, Miss Compton, but I swear everything in math has a name, and that common sense thing is called closure. Okay, and then let's go to the other common sense thing. An inverse, as a gentle reminder, in case you have forgotten, or in case you didn't know. An inverse is when you're trying to get back to the identity. So with addition, we decided specifically the identity thing was 0. So the inverse will help me get back to 0. So if I pick x, and I need to get back to 0, what do I need to do? Yes, she's flipping the fractions and doing reciprocal fractions, which is perfect. We're going to keep table 6 hammer point. We're going to keep it way simpler than that. We're going to say, you know how you just subtract it, but again, our column specific, and this is Miss Compton being really particular, our column says that we're doing addition. So I'm going to put that we're going to add the negative version of our number. So we had pink, and now we're adding negative pink, and that gets us back to 0. I get it's stupid to have a plus minus, get that, but again, the column says we're doing addition, so we've got to make it addition. And you already know an example of that. Your favorite number? Low. 5. 5 plus negative 5, isn't that 0? Okay, does anyone know the multiplicative inverse? And table 6 was on the right path, so I'm hoping she can see it through. Yes, dear?
Okay, so you guys do it to get points or something?
Yes. So if I pick, that gets you 1 point. Here's how to get another point. If I pick z, what do I need to multiply by in order to get 1? Can I let them steal it? They're dying. Table 3. 1 over z. And that's really what you were saying about multiplying by the reciprocal. Z over 1 times 1 over z, they end up canceling out. And I knew you knew it, table 5. I knew you knew it. I'm sorry. Okay, table 5, since I didn't pick on you. What's your favorite low number? Low. 3? Okay. So 3 times 1/3 is 1. 3 times a third is 1. You knew that. That's an easy one. Okay, so basically, long story short, if you see 0 showing up on the paper, it's either going to be in the identity or the inverse property. You got to pay attention to what's going on, but it's going to be one of those. And if you see 1 showing up on your paper, it's either going to be in the identity or inverse property with multiplication. Now, before I forget and go over the last column and you tune me out because you assume we're done, let me be very specific. I'm so sorry. I'm so sorry. And yes, I get the distributive property includes both multiplication and addition, so you can just put distributive property. But on your worksheet today, in order for oh, he's been zoned out and I've forgotten his name. Tim, isn't it? Is your name Tim? What is your name? Yes. Tyler. Oh, I knew it was a T. Doesn't that count for something? Okay. Tyler. Okay. Tyler is going to not hear me say this, but he's listening now, and then to learn his name. He needs to not just put inverse property. He needs to put inverse property, and then is it addition or multiplication? So on his paper, his answer should be something like inverse. He can put prop, because he's lazy. And then he can put of multiplication, but he's lazy still, that's fine. He might put inverse prop volt, and I'll understand what that means. If he starts doing like IPOM, I don't know what that means. I'm going to need a couple more letters than that. But he's got to specify is it multiplication or addition, because I'm not psychic and I'm not assuming he knows what he's doing because this is his first day. Okay. Our last and final property, and then it's on you to practice it. Good grief. Is the associative property. Let's use different letters. We hadn't used port E. E and F
J.
plus G. No, once you start going to the alphabet, you gotta. Okay. If I add E and F first, and then add G, isn't that the same thing as adding F and G first, and then adding E?
Yes.
Does it really matter what order we add numbers in if we're just adding a bunch of numbers? Like, I get there's PEMDAS, but if we're doing Taylor, your favorite number? Low.
24.
That's not as low as I was wanting, but okay. 24. Someone with a real low number. 2. And I heard a 7. Okay, 24, 2, and 7. 24, that's 26 plus 7 is 33. 33? This is why low. 9, 20, yeah, it's 33. Okay, so the left side's 33. And then on the right side, you would say, Miss Compton, you're supposed to add 2 and 7 first and get 9. But hey, 9 plus 24 is also 33. So it does not matter what order we actually add in. In the same way. Yes, Hunter.
Does it matter when you subtract?
He asked if it mattered if we subtracted. And probably because we're probably going to make a sign error. Probably so. We should probably ignore this rule and stick to our PEMDAS-y ways of doing parentheses first. But just in my mind, if I'm adding 3 numbers, does it really matter if I do the first 2 and then the third, or the last 2 and then the first? Does it really matter? That was a good question. You can have a point. Okay, and then the same property works. We'll do K's and L's. K times L times M is going to be the same thing as K times L times M done first. And this is true for real numbers. But the smarty who already understood matrices, this is not true for a matrix. This will not work for a matrix. Okay, I'm going to pick the numbers because I'm scared of the high ones.
Do 8.
I can do 8.
Okay.
I can do 8 times 2 times 3. So I'm doing 16 times 3, and that's 16 times 3. 16 times 3. Table 2 gets a point. Or I can do 8 times 2 times 3. What's 2 times 3? And then 8 times 6?
8 times 6 is 48.
Table 3 had it first. So, which is surprising because, my gosh, we were hoping to get the same number both times. Duh. So 48 does equal 48. Okay, are there any questions about this? You get the handout. You have to identify the property. Now is our time to practice. Your group will finish this quickly, I'm sure. I know you will. I don't care if you work with your group. I don't care.